Welcome. Today we are exploring a fundamental shift in how regulated industries deliver software. We are moving beyond checking boxes at the end of a cycle to a model of compliance by design. We will discuss how FeatureOps allows us to bridge the gap between the need for speed, especially with the rise of AI, and the absolute necessity for secure, auditable, and regulated releases. I am Sousa, and I'm working as the head of engineering at Unleash. My responsibility is to balance project delivery with building a healthy engineering culture across our product development and level 1 support squads. In addition, I'm acting as interim DPO and responsible for compliance in Unleash, which gives me the opportunity to define the security and privacy posture of the company. Part of my day job is to get Unleash SOC 2 certified every year and to help our customers in their compliance needs when they are adopting Unleash. Our session today is divided in 3 parts. First, we'll expose the compliance gap, the hidden crisis created by dynamic runtime changes and AI. Second, we'll introduce the FeatureOps solution, embedding governance directly into your tools. And finally, we'll look at real-world validations of these concepts from global leaders like Lloyds Bank. Here we go with the first part. The core problem is a disconnect in visibility. Traditional compliance relies on the CI/CD pipeline as the control gate and the platform that collects compliance evidence. But feature flags decouple deployment from release. This means a system's behavior can change at runtime without any new code being compiled, nor any artifact being deployed. If you're a release manager or auditor looking only at CI/CD logs, the actual state of production becomes a black box. There are dangers when deploying behind the feature flag that takes many weeks to get enabled in production. The problem isn't that static code analyzers will miss it. For example, CodeQL will read all of the conditional code branches. The danger is that dynamic testing and penetration testers are completely blind to it. You are effectively running code in production that has never faced an active security scan, creating a risk that is invisible until the moment that the feature flag is flipped. Unless you have an explicit dynamic security testing phase in production, you will declare your software development lifecycle has a hybrid security approach with SAST and DAST. But you effectively have only SAST for some parts of the code you deploy. SAST, Static Application Security Testing, is great at catching syntax-level security flaws, but is notoriously bad at catching broken object-level authorization problems or rate-limiting flaws or insecure integrations with third-party APIs. If an incident occurs, triage teams can waste hours just trying to identify the active state of the system in production because you have enabled partially tested code that violated your standard change management rules. We cannot assume that auditors aren't watching. Modern tech-savvy assessors now classify feature flags as operational configuration items, subject to the same scrutiny as a database change. During your upcoming audits, if you can't show peer approval for a toggle change from 6 months ago, you are likely facing either of these 2 problems, either a costly or time-consuming and frustrating manual log harvesting for your platform engineers. And AI is acting as a risk multiplier. Tools like Claude or Copilot generate code at a volume that humans can barely review. When AI-generated logic is hidden behind the dark or inactive flags, it is more likely to receive a light peer review. Imagine a developer uses an AI assistant to generate a complex SQL query or a data transformation script for a compliance-regulated healthcare application, for example. Knowing that AI might have edge cases, they wrap it in a feature flag and deploy it dark or disable. And because it's turned off, the team approves the PR quickly. A month later, a product manager flips that flag to 100% active. The AI code executes, but it contains a logical flaw that accidentally exposes patient data to the wrong user roles, for example. When the regulator steps in and asks, where is the human verification for this algorithm? The company, your company, realizes that the peer review process was partially bypassed by this dark flag. What is important to notice is that regulators are now demanding algorithmic accountability. You must be able to prove human intent and oversight for the code that your system is executing, even if a machine wrote it. In the case of a data leak or an outage, claiming ignorance is not a legal defense. The regulations with these algorithmic accountability principles are present both in the US and the EU, such as the examples that we see here listed from the Federal Trade Commission or the SR 11.7 from the Federal Reserve, even the EU AI Act. So to summarize this first part, our pipelines are disconnected from runtime reality. The dormant code behind the feature flags is creating silent risks, and the auditors are narrowing their focus on feature flags. This is the crisis where engineering velocity is colliding head-on with the compliance rigidity, and we need a new architectural approach. Let's move into the second part. FeatureOps is the answer, and let me introduce you to that. Instead of treating compliance as a manual hurdle at the end, we integrate governance directly into the release tools. By automating policy workloads for every flag, project, or environment, compliance becomes a native, invisible byproduct of the developer's existing workflow. We provide a safety net that allows engineers to focus on creating business value. It all starts with access control. We enforce the principle of least privilege through granular, role-based access control. Developers retain full freedom to debug and experiment in non-production environments, but production gates are strictly restricted to specific authorized roles. This simple isolation eliminates the risk of accidental or unauthorized flag flips in the live systems. To solve the human oversight problem that I mentioned earlier, we enable the 4 I's principle. No single individual has unilateral power to change production logic. Every production change must be drafted as a change request, peer-reviewed, and tested before it can go live. The company roles, designated as approvers, can inspect who triggered each step of the change request and when. This ensures that even fast-moving AI code always has a verified human sign-off. Every action in the system must leave a mark. The most important actions in Unleash leave an audit trail, such as user administration, for example, creating new roles, feature flag lifecycle, creating them, removing them, and project level and environment changes. Our audit trails are automated, and they capture the 4 foundational data points or metadata: the identity, who did the action via SSO, the timestamp, so exactly when that change in the system happened, the diff, or the exact difference between before and after states of the system, and very importantly, the context. Normally, this can be the Jira or ServiceNow ticket that relates to the change, that normally contains the why that is so important in the human intent, right? Or the traceability of your AI code. All of this covers the compliance needs with zero manual effort. Data privacy is non-negotiable in fields like healthcare with HIPAA compliance framework, for example, or finance with the PCI standard. Using Unleash Edge, the feature targeting decisions happen locally within your secure perimeter. PII or cardholder data never leaves your network to traverse the public internet. You get the benefits of dynamic feature management at low latency with the security of a localized, hyper-compliant architecture. Compliance also means resilience. If a feature fails, a traditional code rollback can take 45 minutes of high-risk redeployment. Feature flag kill switches act in milliseconds to contain the failure. By instantly limiting the blast radius, you turn a potential catastrophic outage into a minor remediated hiccup. So, by designing compliance in your software development lifecycle, we have secured access at the environment level granularity with RBAC. We have enforced governance using 4 ICE principle with change request. We have automatically included audit trail with timestamps, identity, and the context metadata. We have isolated PII within your security perimeter using localized evaluation with Edge. And we have increased resiliency with kill switches that reduces blast radius and consequently reduce incident recovery time. We've turned manual process with high friction into a set of automated workarounds for your developer workflow. All right, let's move into the last part of the session, and let me show you how this looks like in real world. Lloyds Banking Group provides a perfect example. They manage over 1,000 developers across 20 platforms. By treating feature flags as shared enterprise infrastructure rather than loose configuration per product or per team, they provided projects and team autonomy while maintaining strict controls in production. They leverage change requests and audit logs to make their development process ready for audits. At the same time, their central team has enabled developers to onboard Unleash without friction in their developer portal, which reduces their adoption overhead. The result? They accelerated releases by 35% while creating a compliant foundation for AI rollouts. This is not just theoretical. This we map directly to the frameworks that you care about. And you can see the specific controls for each framework in this list here. We support SOC 2 through change requests. We support PCI via centralized audit logs and that are exportable to your CM stack. HIPAA through localized edge evaluation. We support FedRAMP via project level RBAC paired with mandatory peer approvals for production changes. And also ISO 27K with complete traceability chain of the flags from the Jira intent to live production runtime. As we close, just remember this key concept. Decoupling deployments from release is now mandatory for DevOps and Agile organizations. FeatureOps allows you to unify these speed and adaptability principles with strict compliance boundaries. And by automating the audit trail and enforcing human intent for AI, you ensure that compliance is never a roadblock, it's just built by design. Thank you so much.
All righty, here we go.
Hello.
Thank you, everybody, for staying with us. And here we also have Diego for some Q&A. If you have any questions or doubts, feel free to ask anything. We will start with some discussion. Diego, first of all, thank you for your time. Thank you for the session.
Here.
I remember, and we have mentioned it in a few times today in some other sessions too. We have mentioned the ServiceNow integration, or maybe some customer using ServiceNow automation to simplify the compliance process for auditors and so on. Can you tell us a bit about that? And also, can you share anything that maybe might become available for the rest of the customers that are interested in the future?
Yes, definitely. In the part of the presentation where I talk about the audit logs and how they provide the 4 fundamental points for your compliance, one of those points is the context, right? What was the context of the decision that led to a certain feature flag change? Normally, the context is either in Jira or ServiceNow. That's what we see in the majority of the customers. Now, we've been working closely with a handful of customers that use ServiceNow. We also observed a couple of customers that have built integrations with ServiceNow. And we are now in the process of designing our own ServiceNow integration, which would hopefully solve this problem in the most generic way, or in a way that solves the problem for the majority of our customers. And of course, this is a work in progress, and I cannot provide an estimate or a specific release plan, but we are working on it.
That's great to hear. Thank you, Diego. So if you're interested, by the way, just drop a message on our community Slack. Maybe, we can get you involved as soon as we have something ready to share and to beta test maybe. All right, let me see if there's any other question. So Diego, you mentioned the idea of ghost controls, as in, feature flags from the past that maybe accumulated over time, and they kind of hide code paths that are not maintained anymore, and maybe they will end up bypassing security standards and so on. I wanted to ask you, does Unleash offer anything that could help with that, like native governance policies or automated alerts or hard expiration limits? Can you share anything about that?
Yes, there are several things to mention. Let me try to organize a little bit the order to mention them. But from top of my head, there are several things that contribute to the governance of the feature flags, right? I would probably list them in the not the most optimal order, but bear with me. One of the things that is directly very visible is the feature flag lifecycle. So whenever you are operating a feature flag, the system will be, depending on the usage you do, will be tracking different lifecycle stages: define, develop, production, cleanup, archive. So that will basically give the operators, not just the teams in doing the projects, but also the central teams, platform teams, DevOps teams, a complete visibility of where in that life cycle is each feature flag. Another feature that Unleash has is the staleness detection, because the different types of feature flags are have an expected lifetime, different expected lifetime. Some feature flag types like release have 40 days, others have 7 days, and others have longer. So with this visibility, the Unleash system is also marking each and every flag with the potential stale attribute. And this allows you a few things as an operator of the system. Because when the feature flag is marked, an event is emitted also. So Unleash emits an event that's called feature stale on, right? With that event, you could potentially channel that into Slack channel notifications for specific teams or team leaders, for example, specific roles to detect those events. You could also break your CI and CD pipeline if you want to be strict on that, or you can even automate opening pull requests to fix the problem of the potentially stale flag by removing the flag or accounting the flag. And another feature that Unleash has is the project status dashboard and the technical debt rating. This rating is like a health score that combines the status of your flags, how many of them are healthy versus stale or potentially stale. So with that simple number, also the operators of the platform can detect, okay, list all of the flags per projects or teams, and they can have an idea of which teams are basically falling behind in their technical debt, and of course help those teams. That's this list. Also on the list, when you list and browse the flags, you can filter them by status, so you can just narrow down your focus on the stale flags.
That makes a lot of sense. Thank you, Diego. I think we have a little comment or question from David. Let me pop it up into the screen. He's asking, are the flags part of the hygiene system? I'm not fully understanding the scope here. Is that clear for you, Diego?
No, doesn't ring a bell for, well, maybe I have an interpretation for the question. What I was describing, if the question came up, a minute ago, while I was talking about the life cycle of the flags and the different classification of stale or not stale, that is a hygiene system in the sense that it provides a recommendation to the team. It doesn't change the configuration of the flag arbitrarily or automatically. It is a recommendation. It says, that's why I understand, probably it's a hygiene system in the sense that it will let you know that you have potentially stale or stale flags, but it's up to you to act on them.
That makes sense. And David, if that's not what you meant, feel free to clarify and ask another question. Diego, you also mentioned an example of a customer who has a lot of developers, I think over 1,000 developers, and they use environment-specific role-based access control. I know that's pretty sophisticated, and we provide that, of course. I wanted to ask you, how does Unleash allow you as a customer to segment access so that maybe a centralized platform team can centralize all the compliance guardrails that you need? And maybe that's easy to do, but what I mean is, can you do that without slowing down all the business units so that they can still be autonomous and own their specific project configuration?
Exactly. This is very critical. The more you grow, right? The bigger you grow your organization, this more relevant this question becomes. And yes, of course, it is possible, but you have to combine a few layers that I'm going to try to explain. You have to combine a few layers or a few features of Unleash in order to achieve that goal of having some central things for the platform team, normally or developer experience team, the one that wants to make sure that all the projects or all the teams are following certain guardrails, and at the same time leave or open the room for those teams to be as autonomous as possible. So one of the layers or one of the things that come into play here is the two levels of RBAC, roles-based access control. So one is called the root roles, where the central teams will be able to configure things like environments and role definitions, which are, let's say, central resources for the whole Unleash platform. They can also configure SSO and this kind of thing in this, let's call it global settings to the root roles. And then there are project roles that are specific for each team or group of teams inside a project, right? Those are the ones that relate to the governance, daily operation, governance of the feature flags themselves. Now, the central teams can treat this feature or leverage this feature in two ways, let's say less prescriptive and more prescriptive. In a less prescriptive approach, they will set up certain defaults, and then the specific project teams can override those defaults. In a more prescriptive approach, they will just determine how they want the projects and environments to be configured to satisfy, for example, their compliance needs, and no project members can change that, right? This is achieved by a combination of certain things, right? We have environment-specific permissions within the project. So within each project, you can create roles, different roles that have different permissions across the environments. Typically, a developer role can have full permission on the developer and staging environments, while in the production environment, they can only change things through change requests that need to be approved to reinforce these 4 I's principles that I was mentioning. While other roles that, like the DevOps or SRE teams that really need to react to the biggest incidents, they can have full permission on both development, staging, and production. In addition to all of these features, there are several things that you can automate to bring this to scale. One is the setup of the projects using Terraform. You can automate those guidelines, how you want your projects to be set up. And with the other integrations of single sign-on and Scheme, you can integrate your identity providers in such a way that the provisioning of your users and roles comes automatic from your other HR, IT system or IT systems.
That makes a lot of sense. Thank you. Thank you so much, Diego.